Okay, so I will be discussing with you today a project that I did at Capital One, where I was trying to sleuth for adverse outcomes using anomaly detection. So the context that this project occurred in is this relationship between a financial institute and its customers, which is often mediated by a third-party agent. So a classic case of this occurs with mortgages, where you have a financial institute that would like to give a mortgage and a customer that would like to receive one, and a mortgage broker who mediates that relationship. So in an ideal world, you would issue loans based on the customer. You would assume that the third-party agent has very little to do with modifying any sort of hazards or outcomes that would occur in that situation. But as we know from events that occurred prior to the Great Recession, this is not always the case. So the third-party agent and the actions that they take can make a difference to outcomes, which is something that as a financial institute we would like to better understand. While there is usually very strong supervised models that are created to describe whether or not you want to issue a loan to a customer, we want to use anomaly detection on top of that to create a better understanding for how third-party agents interact in this relationship. So in order to understand that, we took two different approaches, one of which worked and one of which didn't, but it's interesting. So the first thing that we tried is a customer-first approach, where we used anomaly detection on all of the different customer profiles that we had, and then we took averages of the anomaly scores that were generated to say, here's an agent who's maybe more anomalous than another one. Should we consider them for further action? This did not work particularly well, and the reason for that is something that occurred quite a lot in business contexts with anomaly detection. What you see is that there are customers who have unusual profiles, but those profiles are unusual in ways that are not really business impactful. There may be people with special circumstances, and so they look different than the more ordinary population, but you're not looking to adjust any business decisioning based on that, so anomaly detection on that feature set doesn't result in anything you could do anything with. What worked better, actually, is when we took more of an agent-first approach. And so I turned to a subject matter expert, and they generated a laundry list of 80 different sorts of behaviors they thought might be strange on the behalf of a third-party agent. And then I constructed features based on, for each of those agents, how many different customers did they interact with, where the structure of the account had certain properties. So what you get instead is the laundry list of features that show a proportion of behaviors engaged in, and that's what I performed anomaly detection on, and that actually worked rather well. So to see the outcome of that, and to give more concreteness to the way that this all worked, this is sort of a human timescale process. So you have to first gather agent behaviors over the course of 2 quarters, and then you have to perform anomaly detection then, to rank order your agents and say, these are the ones who I might want to take further looking into, and these are the ones who seem more normal. Then those agents go on and they initiate accounts with different customers. You perform supervised learning on all of those accounts as they're initiated to create a benchmark for how you expect those customer accounts to turn out. Then, after those accounts have been booked, maybe over 2 quarters, you wait patiently for a while those accounts mature, and then you see what happens. So actual performance, you determine. And the metric that we care about most is anomaly detection doing a good job of finding cases in which something that we didn't expect to happen happened. For this project, we used isolation forests because they were able to accommodate a very large feature set that had many variables that may not have been particularly correlated with the outcome that we wanted to observe. They also ran extraordinarily quickly, which made some post hoc feature engineering or understanding more accessible. In this particular case, we see that anomaly detection actually did a very nice job of sloping an unexpected behavior against the normal population. So in the graph that's on the upper right-hand corner, you can see that when you order these agents from most anomalous to least anomalous, you do see a distinctive sloping in the difference between the observed outcome for all of the customers that they interacted with and what you expected to happen. So with that, you could use different sorts of time samples. You could look at which features were the most important using an optimization technique. And what you see is that there's a core set of behaviors that are important to this sort of determination. This, in total, gives you a general framework that you could think to approach problems similar to this, particularly in cases where you don't have a supervised model to benchmark against, but where you do have a relationship you want to further understand involving a third-party agent. So thanks.